Hello everybody. Well, you should have your notes out by now. And the last time we took notes, I had you do, let me get this out of the way. It was notes number 4, atomic mass units versus molar mass. And this was just to show you that atomic mass units, in this case 18 atomic mass units in a molecule of water, converts into 18 grams per mole of water. So that was just a step that normally we don't do all this. We just say you look on the periodic table, figure out how many atomic mass units in the atom or molecule, and then that directly converts over into molar mass, grams per mole. So we're working on molar conversion chart. I would recommend that you make this at least have half a page. It might be good to even make it a full page. This is a pretty helpful tool, and I'm going to give you some hints as we go. So the molar conversion chart, and converting moles from mass into moles, or moles into number of particles, particles into volume of gas. So this chart will help quite a bit. So I'm going to begin right here, work in the middle here, and what we're going to do, we're going to start in the middle of this area. Now we're going to end up having a triangular shaped chart. So we'll start here. Let's put our friend the mole. And that's just the name for 6.02 times 10 to the 23. Now what we're going to do is I want you to think of the mole as the most valuable player. I know, stupid memory clue. MVP, the most valuable player. Now when we do this, let's put at the bottom left corner, let's put M over here, which we're going to, this M for MVP, and this is going to be mass. Now this is something that when you go to take the test, if you need to have on your scratch paper, you can get this drawn out right away. Most valuable player, V. What do you think the V is standing for, huh? Okay, well if you said volume, that's how much space it takes up. You're right, volume. And then lastly in this bottom corner, P is going to be for particles. Let's get in this far corner. Whoops. Particles. Now by particles we mean atoms or ions, or it could be molecules. Now we're going to put between each of these, our magic conversion number is going to be, well, in a couple of them we need to put the conversion factors. So what we do here is we're going to write between mass and mole, we're going to write molar mass. Let's see, I'll do that in a pink color. So this is molar mass, which is grams per mole. Okay, so let's get that set up. Now between the mole and volume, in the notes before I gave you, we said that 1 mole of a material is 22.4 liters. So we're going to put right between mole and volume 22.4 liters. Okay, so 22.4, that's our conversion number here. And then between moles and particles, it's going to be Avogadro's number, 6.02 times 10 to the 23. 6.02 times 10 to the 23 atoms, ions, or molecules. Zoom in more. Now, what's cool about the chart is that we're going to draw some arrows next, and we're going to draw arrows that are going away from the mole. So when you're converting, when we ask you to convert moles of something into volume, so I'm going to put this right here. When we do that, we are multiplying by 22.4. I'm going to put times 22.4. That'll be the factor you use. In fact, when we do that, and if we're going to have 22.4 liters in 1 mole. That would actually be the conversion factor you would put in. But if you're going from the middle of the chart up to the top, we're multiplying by 22.4, and that would be the actual conversion factor. Now for our friend over here, if we're going from a mole to number of particles, now we're going to draw the arrow going away. Again, I'm doing all the arrows away from the mole first. When we go away from the center of this chart, we are multiplying. So in this case, if you want to change your moles of a material into number of particles, you're going to multiply by Avogadro's number. And this is my times symbol on there. So in this particular case, you would set up, if this was your conversion factor, you would have 6.02 times 10 to the 23 divided by 1 mole. Okay, so again, just conversions. And this chart can help us out for doing multi-step conversions. So now we're going to do the arrow away from the mole, converting into mass. So I'm going to put it over here. Now again, when the arrow goes away from the center of the chart, that's going to be multiplying. So again, we're going to be multiplying by the molar mass. That's going to be the grams per mole. So over here, this would be the molar mass divided by 1 mole. For example, in this problem here, our molar mass we figured for water was 18 grams per mole. So that'll be mass grams, I'll put the G there, grams per mole over here. So if this chart helps you out, cool. But it also works the other way. It's the handy dandy, you can not only divide, but you can also, actually multiply, you can also divide. I'm going to put away my, let's see, I will use my fusion, I'll use a red one now. Okay, so now this time we're going to draw the arrows coming back. So if we've got a problem where we've got to convert, say, 56 liters of nitrogen gas into how many moles, we take our volume that we're given, and this time when we draw this arrow towards, when we want to convert 2 moles, we're going to divide. So this is the divided by side. So you take your volume you're given and you would divide it by 22.4 liters to figure out the moles. And then setting up that relationship for you, that would be 1 mole, 1 mole of whatever gas you're talking about divided by 22.4 liters. I'm going to put a little tail on my L just so we know that's liters. Over here, when we're going from mass to moles, so let's say you have, how many, grams you have of something. Again, we're drawing this arrow towards the center. We're dividing by the molar mass. So this time, it's just going to be the opposite of this one. It'll be 1 mole divided by the mass in grams. How many grams that you have? It's just the opposite. So this, again, our molar mass was 18 grams per mole. Over here we would have 1 mole per 18 grams. So, get that back up. There we go. Centered, so you can center it so you can see it. So now we're just about done with this. We got to finish up over here. So now if we're going to go this way, let's draw our arrow. If we want to go from particles, atoms, ions, molecules to how many moles it is, again, this arrow is going towards the center on our chart. Arrows towards the center, we divide. And this time it'll be just the opposite of what we had over here. Now we'll have 1 mole of whatever it is we were given, and we're going to divide it by 6.02 times 10 to the 23. So we're going to begin pretty soon, in fact even today, we're going to start working on problems where we're going to be doing 2 conversions. Right now we've just been practicing single conversions, mass to moles, or moles back to mass, or moles over here to particles, or particles back to mole, and we did a little bit of, we start today practicing volume, but now we're going to start working on problems where if we give you a volume and we want you to tell us what the mass is of that gas, if the mass is given, if the volume of the gas is given, you would divide by 22.4 to find how many moles, and then to find out how many mass that is, you would then take your moles of that gas and you would divide it by the molar mass, and you'd end up with the mass. So this chart, following these arrows, they can help you when we're working follow a path to convert. So with that, oh, by the way, there's a nice diagram. Let me change my pen color just because I can. This is found, if you need better reference for it, this is figure 10.12, found on page 303 of the textbook. You can pretty it up and look at it, but it's pretty nice because it lets you do some conversions. Well, let's just do a quick practice one here. Let's say, you know what, I'm going to stop for there because this is getting long. So we've got this chart here to help you out, and I'll talk more about it later, but there you go. And if you need to, here we go. Oh, look at there. There it is. But the main thing, the reason I wanted to have you go through this with me is that any arrow going away from the center, we're multiplying by the main factor. We're multiplying by 22.4, we're multiplying by 6.02 times 10 to the 23. We're multiplying by whatever the molar mass is of the compound. If we're going from the outside of the triangle to the middle, we're dividing. And that can be something that can really help you out if you're visual. So with that, we're going to end this here. So, cut. Oh, dang it. Wait a minute.